Welcome to A-Level and AP Physics. In today's lesson, we will talk about stationary waves and polarization by solving past paper question from March 2022, Paper 2, Variant 2. In this class, we will discuss some important concepts about waves and polarization. For part A1, we need to state the conditions required for the formation of a stationary wave. So let's try to understand how a stationary wave can be formed. First of all, in order to form stationary wave, we need two different waves, and these two waves, they have to overlap to form a stationary wave. So simply we can say this is also required condition, and these two waves, they have to travel in opposite directions, otherwise stationary wave will not be formed. So waves have to travel in opposite directions, and this is also true if one wave is reflected wave and one is incident wave. They can also form stationary wave. Next thing we need to understand, waves, they must have same type. Means waves of same type, they can form stationary waves. It simply means that sound can form stationary waves with sound, and light can form stationary waves with light. Or radio waves, they can form stationary waves with radio waves. So this is what is meant by same type. Next thing we need to understand, waves, they must have the same speed. So they must have same speed in the same medium. And also waves must have the same frequency. So we can say same frequency. Same type of waves with same frequency and same speed in the same medium, traveling in opposite directions. When they overlap, stationary wave will be formed. So these are the conditions we need. So if you write down these one, you will get 2 marks. This question has only 2 marks. The first mark you will get if you have written overlap, traveling in opposite directions. So if you write down this one, you will get 1 mark. And if you write down same type, same speed and same frequency, you will get a 2nd mark. So this is for the sake of this question. This is how you can write down the answer. Now let's try to understand stationary waves with the help of animation. First of all, please look at this animation carefully and try to understand what is happening. And then I will highlight the important points you need to understand about stationary waves. If you have watched this animation carefully, in this case you can see there are 3 different types of waves. One is incident wave. This yellow wave, this is the incident wave. So I will write down here the yellow wave, this is the incident wave, and this wave is traveling to the right. So this one is incident wave. We will look at this animation again. So this is the incident wave, and the blue wave, this one is reflected wave. So simply I will write down here, this one is reflected wave, and this wave is traveling to the left. But if you look at green wave, this is the resultant wave of incident and reflected wave. So we can simply say this one is stationary wave. But if you look at this point, at this point you can see the blue wave, this has negative displacement, and the yellow one, this has positive displacement. So at this point we have node. So the node is formed at this point. So the particle at this point has no displacement. Now simply we can say the particle at nodes stay at rest. So particle here, it will stay at rest. Now let's see this animation again. Now you can see here particle at this point will stay at rest because there is no displacement at this position. So this particle stay just at rest. Let's try to find out an other node. If you move to this point, so you can also see here particle at this point is not moving at all. I mean the displacement of the particle at this point is equal to 0. So let me draw a line here so you can see what is happening at the node. So this is over another node. So this is an other node. So you can see displacement at this point is 0. 0. And if you look at this point, displacement is also 0. Now you have to look at stationary wave only. So I will hide in this case incident and reflected wave. So if you look at stationary wave, you can see between any two nodes, all the particles at the same time they will go down, and at the same time then they will reach the peak and they will continue moving in this cycle. So the particles between two consecutive nodes, they are in phase. So simply we can say particle between two consecutive nodes, they are in phase. So very important point. So in phase. So all the particles between two consecutive nodes, mean between this point and between this point. We can also use letter N here. So this is node and this is node. So all the particles between any two consecutive nodes, they are in phase. So the particles between these two consecutive nodes, they are in phase. So this is what you need to understand about stationary waves. I hope it is clear to you. Let's see all the waves again now. So you can see how incident and reflected wave, they overlap and they form the stationary wave. So incident and reflected wave, they have to be of the same type. They should have the same speed in the same medium, and they should have same frequency, and they need to overlap, and they need to travel in opposite directions. This is how we can write down our answer for part A1. Now let's move on to second part. For the second part, we need to state the phase difference between any two vibrating particles in a stationary wave between two adjacent nodes. So first of all, let's try to sketch a stationary wave. Let's say this is our stationary wave. So this one is stationary wave. In this case, you can see we have node here. We also have node at this point. So this is one node, this is an other node, and this is an other node. In this case, all the particles between these two nodes, let's say these particles are moving down. So all the particles, they will move down at the same time, and at the same time they will reach the lowest point, and then again they will start moving up. So all the particles between two nodes, they are always in phase. So we can say these particles are always in phase. If particles are in phase, we can simply say in that case, phase difference is equal to 0. So phase difference is equal to 0. So this is what you have to write down for this question. So simply you can say 0. Phase difference 0. But if you look at particles between next two nodes, so when these particles, they are at the peak, these particles, they will be at the lowest point, and after that they will start moving up. So particles here and particle here, let's say we have particle X. So let me explain a little bit more about that. Let's say we have one particle here. Let's say this is particle X, and let's say we have one particle here, that is particle Y. X and Y, they are in antiphase. So we can say X and Y, they are in antiphase. So these are in antiphase. If we take other particles, for example, particle at this point, let's say this particle is P, and we take an other particle, let's say anywhere you can take. So I will just say, let's say at this point, let's say this particle is R. So P and R, they are also in antiphase. So they are also in antiphase. If we take another particle, let's say we take particle here, let's say this particle is S, and we take an other particle here, this particle is T. So S and T, they are also in antiphase. So we can say S and T. So P and R, S and T, they are also antiphase. Means the phase difference between them is equal to 180 degrees. It simply means that when this particle is moving down, these particles will be moving up. For part B, it is given to us a motorcycle is traveling at 13 meters per second along a straight road. The rider of the motorcycle sees a person standing in the road directly ahead and operates a horn to emit a warning sound. The person hears the warning sounds at a frequency of 543 Hz. The speed of the sound in the air is given. We need to calculate the frequency to three significant figures of the sound emitted by the horn. This question is about Doppler effect, and in this case, source is approaching. So simply we can label this is motorcycle. In physics, if you don't want to draw something, you can simply label that. So this is motorcycle, and this motorcycle is approaching an observer, and this observer is at rest. And speed of the motorcycle is given, means speed of the source is given, that is Vs, and Vs is equal to 13 meters per second. In this case, source is approaching, so we have to use Doppler effect for approaching source, approaching. So observed frequency simply will be equal to speed of the wave in that medium divided by speed of the wave. In this case, source is approaching, so it has to be negative because observed frequency has to be greater than frequency of the source. In this case, this frequency is observed frequency because this is the warning sound heard by the person. So this is our observed frequency. We have to find out Fs. So simply we can plug in values here now. Again, we can write down this is observed frequency. This is equal to speed of the wave, means this is speed of the wave in that medium divided by speed of the wave minus speed of the source multiplied with frequency of the source. Observed frequency in this case is given, that is equal to 543 meters per second. Speed of the wave is given, this is 334, so again we have to write out here, and speed of the source is given, that is 13, and we have to find Fs. Now simply if we solve this, we can find out frequency of the source, and frequency of the source up to 3SF will be equal to 522 Hertz, and this is right answer because in this case source is approaching, so the observed frequency has to be greater than frequency of the source, or we can say Fs has to be lower than observed frequency. So this is our final answer. We can write on here 522. This question has only 2 marks. You will get 2 marks if you have plug in values, means you have sub values, right values, and you will get 1 mark, and the final mark is answer mark if you have got the right answer. For the second part, it is given to us the motorcycle rider passes the stationary person and then moves directly away from her. As the rider moves away, he operates horn for a second time. The person now hears the sound that is increasing in frequency. It simply means that observed frequency is increasing. We need to state the variation, if any, in the speed of the motorcycle when the rider operates the horn for the second time. So the first thing we need to understand, in this case, source is moving away. So simply we can write down, first of all, source is moving away. Means observer is standing here, observer is at rest, and the source is moving away. So this is our motorcycle that is moving away, and motorcycle is the source. Motorcycle is moving away. Now we need to understand how we can write down Doppler effect for a moving source that is moving away from observer, means from stationary observer. So observed frequency in this case will be speed of the wave divided by speed of the wave plus speed of the source, and this has to be multiplied with frequency of the source. Now in this question, it is given to us that frequency is increasing, when observed frequency is increasing, but frequency of the source is same, is constant. Frequency of the source is constant, speed of the wave in the same medium, same wave, same medium, so speed is the same because speed of the wave depends on type of wave and medium, so that is the same. Now if F not increase, it simply means that speed of the source is decreasing. So simply you can understand from here, this is a special case when the speed is decreasing. So if the speed is decreasing, observed frequency will increase. If speed increase, you will see observed frequency will decrease with time, means frequency will not be constant. If the source is moving at constant velocity, observed frequency is constant, but if the source is slowing down, observed observed frequency will increase. But if the source is speeding up, observed frequency will decrease. Mean if this increase, so I will be using dotted line. If this increase, observed frequency will decrease. So simply for this question, we need to understand speed of the source is decreasing. So we can say speed is decreasing. And this question has only 1 mark. So simply you need to write down speed is decreasing and you will get 1 mark. And this is B mark. For part C, it is given to us a beam of vertically polarized monochromatic light is incident normally on a polarizing filter as shown in figure 5.1. So in this case, you can see we have vertically polarized light, means this is vertically polarized light. So this is vertically polarized light. And here we have polarizing filter that is placed in front of that. And the angle between vertically polarized light and transmission axis is 20 degrees. And here we have over transmitted light. So this will be transmitted light. Intensity of transmitted light is given, that is IT. Question is asking us to calculate the ratio between amplitude of transmitted light and amplitude of incident light by considering the ratio between IT and I naught. And we need to show overworking. Means we have to write down all the steps. So we can start this one from intensity, mean the relationship between intensity and amplitude. Intensity is directly proportional to amplitude square. From here we can also say that intensity over A naught square means the ratio between these two remains constant. So we can say this is constant. So in this case, we can also say that intensity of incident light over amplitude of incident light square, this will be equal to intensity of transmitted light over amplitude of transmitted light square. If we rearrange this one, we can write down IT over I naught. This one will be equal to AT square over A naught square. We have to find the ratio between these two. So we can also write down here that AT over A naught square, here we have square, this is equal to IT over I naught. Or we can say AT over A naught, this is equal to IT over I naught square root of that. Means the power of this one is 1 by 2. Now we need to find out what is the ratio between IT and I naught. And the power of that one will be equal to 1 by 2. So let's try to find out the ratio between IT and I naught. For that purpose, we have to use Malice's law. According to Malice's law, IT means intensity of transmitted light. So we can say transmitted light. IT, transmitted. This is equal to intensity of incident light. So I will be writing I naught here for incident times cosine square theta. Theta is the angle between vertically polarized light, meaning the polarized light, and transmission axis. And angle in this case is given, that is equal to 20 degrees. So we can say this is cosine square 20 degrees. Now from here we can write down IT over I naught. This is equal to cosine square of 20 degrees. We can solve this one and we can find out value of this. Now we have found the ratio between IT over I naught. So simply we will plug in here. So IT over I naught is equal to cosine square of 20 degrees. Now if we simplify this one, we can cancel this power with this. Means we can cancel this 2 with this 2. So simply we left with AT over A naught. This is equal to cosine of 20 degrees. And simply now we can use calculator and we can find out value of cosine 20 degrees. And cosine of 20 degrees is equal to 0.94 up to 2 SF. And this is over final answer. This question has 3 marks. You will get the first mark, that is B mark, if you have written the relationship between intensity and amplitude. Means if you have mentioned this one, you will get first mark, that is B mark. And the C mark you will get if you have written this step, you will get the C mark. And and you will get the final mark, that is answer mark, if you have got the right answer. So this is answer mark, and this is how marks will be awarded for this question. For the last part, it is given to us the filter is now rotated about direction of the light beam from its starting position as shown in figure 5.1. Direction of rotation is such that angle of transmission axis to the vertical initially increases. So in this case, we need to understand this is vertical and this is transmission axis. So the angle between vertical and transmission axis has to increase initially. So if we rotate this one counterclockwise, angle between them will decrease initially. So that is not what you need to do. We have to increase the angle initially. So simply we have to rotate this one in clockwise direction. We need to calculate the minimum angle through which the filter must be rotated so that the intensity of the transmitted light returns to the value that it had when the filter was at its starting position. Let's try to understand this one with the help of Malice's law. According to Malice's law, intensity of transmitted light is equal to intensity of incident light times cosine square theta. In this case, intensity of transmitted light means IT at the starting, so we can say at starting position has to be the same as intensity of transmitted light at final position. So these two has to be the same. If IT has to remain same, I naught is fixed, so the cosine square of theta also need to remain same. So how cosine square of theta can be same? In order to understand that one, let's look at this angle first of all. In this case, first of all, angle between vertical and transmission axis is 20 degrees. Now we have to rotate this one clockwise, so the angle between vertical and transmission axis is again 20 degrees. So in this case, you can see here, if we rotate this one by this much, when this angle is again 20 degrees, it means intensity of transmitted light again will be the same. So you can see this total angle is 180 degrees. So we have 20 here, we have 20 here. So the angle we have rotated this polarizing filter, that angle is equal to 140 degrees. Because the total angle from here to here, this is equal to 180. So in this case, 140 plus 20 plus 20. This is equal to 180 degrees. So in this case, we have to rotate this filter by 140 degrees. And this is our answer.